Okay, example 6-5 is about a free hydraulic jump in circular cross section. So usually it happens in wastewater or sewer pipeline or in culverts. So here we have a circular culvert with the diameter of 1.8 meter, which carries a discharge of 2.8 cubic meter per second. So the supercritical depth in a hydraulic jump occurring in this section measured, and it was 0.5 meter. So Y1 is 0.5 meter. And then we need to determine the conjugate depths using the equations that provided in the book. So we have 4 equations that provided by the researchers from 1978 to 2009. And we want to know whether all these equations give you the same value for the conjugate depths in circular channel, or some of them are different. So we start with the Straub equations that referred into Subramania book. First, we need to calculate the critical depth, which is a nonlinear function of discharge and the diameter of the pipe. So if you insert the values, you will get YC equal to 0.816. Then we need to calculate the parameter phi, which is the relationship between critical depths and Y1. So it's YC divided by Y1 to the power of 1.93. It gives you a phi value of 2.58. Then you compare to see whether it's less than 1.7 or larger than 1.7. So if it's less than 1.7, we use the simpler equation that is provided here. And if it's larger than 1.7, then we use the other equation that is provided here. Okay, for our case is 2.58, so it's larger than 1.7. So Y2 divided by Y1 is equal to 1.087 YC to the power of 0.07 multiplied by YC over Y1 to the power of 1.73. So you'll see that those equations basically comes from laboratory experiments by doing regression analysis. So this method gives us Y2, the conjugate depth is equal to 1.25 meter. It is still less than the diameter of the circular pipe. So for the second method, we need to determine the value of Froude number at the upstream. So Froude number in circular pipe is equal to Q divided by G d by 1 to the power of 4 and everything to the power of 1/2. If you calculate, you will get 2.66, which is weak jump, so classified as weak jump. Then Subramania provide a polynomial equation, very straightforward equation, which is only function of Froude number. And you get Y2 equal to 1.28 meter. So you see that it's only 3 centimeter different from the previous equation. So Hager provided a relatively complicated equation, which we have a known value in the left-hand side and unknown value in the left-hand side and the known value in the right-hand side. So if you do the calculation in the right-hand side, you will get 0.6. So this is the right-hand side. And then here we have the left-hand side. So the denominator of the left-hand side is 0.722. And if you do the calculation, you'll see that this complicated equation gives you 1.281, which is very similar to the relatively simpler polynomial equations by Subramania. Maybe that's one of the reasons that pretty much after 20 years, Subramania comes with the relatively simpler equation. And then Stahl and Hager in 1999 provide another equation which is relatively simpler, but you need to use try and error because in the right-hand side you have Y2 in 2 different terms. So if you do the try and error, you will get 1.35. And if you compare it, you will see that it's overestimate Y2.